Hello Precalculus student, this video is for chapter 6.3 inverse trig function. Our goal is to define 6 inverse trig functions so that sine inverse is the inverse function of sine, cosine inverse is inverse function of cosine, etc. For tangent, secant, cosecant, and cotangent, because that's their corresponding sine, tangent, secant, cosecant, these 6 trig functions. So there's a few. Okay, so what is the use of them? Originally we have sine, tangent, all those 6 trig function where our input is an angle or an arc length, right? X, and we would map it to sine x or cosine x, or the 6 of them. So the inverse function will actually map the output. So this would be like 1/2 root 2 over 2 back to the. So this is the function, and this would be an inverse. The inverse will map the answer that you read off from the unit circle map to the angle. So the inverse function sine, inverse cosecant, inverse cotangent will get the input from the corresponding trig function and map it back to the angle in radian, of course. So there's a few things that we need to take care of. First, these original sine and cosine and inverse function, you can actually know after we graph them that they are not one-to-one, right? Sine function are like this, but it goes on forever. So what is one-to-one function? One-to-one function are where you have it obey the horizontal line test, but if we do a horizontal line in any place between 1 and -1, you have a lot of numbers that would intersect the horizontal line. So none of these functions are one-to-one function. So in order to create this 6 inverse function, we pick some range of the domain in the original function, and we restrict it so that the function become one-to-one. So for sine, we pick from -2 over 2. Okay, so if you remember how to graph sine function is like this, right? It actually would repeat on this side. So what we do is we just pick this -2 to positive pi over 2. Negative pi over 2 to positive pi over 2. So why would we pick this is it include all the output from 1 to -1 or -1 to 1. So our input, the input for the inverse function would be from -1 to 1, and then the output would just be negative pi over 2 to pi over 2. And for the same for tangent. Tangent has a graph from there's a two vertical asymptote and negative pi over 2 and pi over 2, but between them tangent actually goes from -infinity to infinity, right? So this is sine. And for tangent, if you still remember the graph, you would have 2 vertical asymptote and it just go forever, right? It would cover, so this would cover all possible value of tangent function, but it would map to an angle between negative pi over 2 to pi over 2. And then for cosine, we would pick from 0 to pi, because what happened is cosine's function is from the top to the bottom and then to the down, right? So from 0 to pi, it would cover from 1 to -1. So everything that you have would include it that is the output of cosine would have been covered. So these are the restricted domain of the original function that you use for sine, cosine, and tangent. So remember, these are like that. So let's look at how we understand the inverse function. So if we remember the unit circle, so whenever we evaluate something, we use the unit circle, right? So I have a unit circle formula or the paper here. If I want to do sine pi over 6, that I would say 1/2, right? This is the input of the sine function, pi over 6, and the output is 1/2. So if I go back to my original notes, I say sine pi over 6 equal to 1/2. And because pi over 6 is in the selected interval from negative pi over 2 to pi over 2, so I can define sine inverse 1/2 will be back to pi over 6. So the inverse take the output to the input. The answer to the inverse function is an angle. Okay, cosine 3 pi over 4 is negative root 2 over 2. So let's look at cosine 3 pi over 4. 3 pi over 4 is over here. Cosine is the x value is negative root 2 over 2, right? So we write it this way. So we would say cosine inverse is of negative root 2 over 2 will map back to 3 pi over 4. Okay. So we do not map it to other place because 3 pi over 4 is from 0 to pi. We only look at those range of negative 3 pi for sine, negative pi over 2 to pi over 2 for cosine, 0 to pi. Tangent negative pi over 3 is negative root 3. How do I know? So where is the unit circle we only have from 0 to 2 pi, but where is angle negative pi over 3? Earlier we say we want tangent negative pi over 3 because negative pi over 3 is within our picked domain of negative pi over 2 to pi over 2. It's because, if you remember, a negative angle is a opposite clockwise rotation. So all these label of 11 pi over 6, 7 pi over 6, 5 pi over 6, we could actually relabel them as negative pi over 6, negative pi over 4, negative pi over 3. So this is the positive side and this is the negative side in this fourth quadrant. So actually negative pi over 2 is right here and pi over 2 is here. So you can actually create a unit circle that have negative angle. So negative pi over 3 actually is the same as 5 pi over 3. So that's why it's equal to negative root 3. And because this is in the restricted domain, so I can say negative inverse tangent of negative root 3 would give back to negative pi over 3. Okay, so basically you can say for sine and tangent, you use this to of the unit circle, this is the positive angle and this is the negative angle to do the inverse. Okay, for sine and tangent. And you do not call this 3 pi over 2, you call this negative pi over 2, negative pi over 6, negative pi over 4, and negative pi over 3. Okay, positive, negative. And then for cosine, you read off from here 0 to pi. Okay, this is for cosine. If you have angle in this range, you can read off the inverse from here. Okay, so basically sine and cosine, sine and tangent use quadrant 1 and quadrant 4. Cosine use quadrant 1 and 2. Because cosine is positive here, cosine is negative here. But the angle is from 0 to pi. So remember the restricted domain. And you can see because we restricted the domain, so the range of an inverse sine function is only between negative pi over 2 and pi over 2. The inverse cosine function is 0 to pi, and for tangent is actually the open parenthesis, negative pi over 2 to pi over 2. Now, there's one thing I want to say. Okay, how do I graph the trig function? So the inverse trig function, can be graphed by the reflection of the original sine and cosine and tangent function. So by reflecting by switching x and y, right? So the original sine function, we say we pick this, right? It was like this, right? And then after you reflect them, it would be this. And then for cosine function, it was this one, right? It was like this. So this is the cosine function from 0 to pi. And so after you do reflection, it would be like this. And then for a tangent function, it was like like this, with the two asymptote. And after you switch it over, you have two horizontal asymptote, and then they go to infinity and negative infinity like that. Or actually, they go to that there is a limit of when x is infinity, it would be close to the arc. The inverse tangent function would approaches pi over 2, and when it is from to negative infinity, the inverse tangent function would go to negative pi over 2. It approaches negative pi over 2. Oh, right. That's something that I want to say. Now I forgot again. Oh, yes, the name. Okay. So the name of the inverse function, we formally would use f inverse, right? Or cosine inverse, use -1 to represent it. But there is also another convention to use arc, arc cosine, arc secant, arc cotangent, arc sine, arc tangent. So they are interchangeable. You can use inverse notation or the arc notation. Find the exact value of sine inverse with 3 over 2. So how do I find it? So the input is the answer, and you're supposed to give an angle. So namely, you would be looking at the quadrant 1 and 4. What angle corresponds to y equal to with 3 over 2? Okay, so let's look at quadrant 1 and 4 because that's what sine's restricted domain is. What y coordinate with 3 over 2? So this is the one, right? And the angle is pi over 3. So when we do sine, we say sine pi over 3 equal to 3 over 2. But when we do inverse, we do reverse lookup. We say, what are the value that is equal to 3 over 2? Give me the angle. So it'll be this one. Now you will say, well, Ms. Chen, this one is also here. Why don't I answer 2 pi over 3? Because sine of 2 pi over 3 is also equal to 3 over 2. It is because we don't choose this as a restricted domain. We have chosen quadrant 1 from pi over 2 to 0, and also from 0 to negative pi over 2. Remember, this case, the quadrant 4 is also chosen because I have a lot of y that is negative, and I will choose this angle, but we'll name this angle as negative angles. So not 11 pi over 6, but negative angles. Okay, quadrant 4 is named as negative. So in this case, it will be pi over 3. Why? Because if from the unit circle, I know sine pi over 3 is equal to 3 over 2. For sine, we only look at the first and the fourth quadrant. Arc sine negative 2 over 2, so that means sine of what is equal to negative 2 over 2 in the 2 quadrant that we have chosen for sine, this 2. Oh, it's this one, right? No, we don't say 7 pi over 4. We say it's the negative. This is negative pi over 4. So this would be, the answer is negative pi over 4. Whenever you pick the angle in the fourth quadrant, it's called a negative angle. What about arc cosine 0? So that means cosine of what equal to 0, right? Cosine of what angle equal to 0? Because this is the input, this is the output, and that would be the input, and this is 0 is the output of cosine. Cosine what equal to 0? Do we know? Cosine is x, so cosine pi over 2 is 0, right? So that would be pi over 2, and there is only 1, right? There's only 1. Cosine inverse, negative 3 over 2. That means cosine of what equal to negative 3 over 2. Do you know? Okay, so negative 3 over 2, cosine is the positive. So with cosine, we look at this 2. The negative cosine are all here. So this would be 5 pi over 6. Right? We for cosine, we only give positive answer. So this is 5 pi over 6. And then tangent negative 3. Now for tangent, we would have to make sure that it is in this 2 quadrant. And then we have to know that for tangent, we have to pre-do some of them because you can't wait until it's because there's no tangent available. So what happened is this is 1.